So today we have third session for this SageMaker, and in this we will complete most of SageMaker regression. So next session we'll take up classification, and after that we'll take up hyperparameter optimization. So first of all, I'm importing pandas, NumPy, Seaborn, Matplotlib. So there is nothing special here. So this file is a Jupyter file which I have already run on the SageMaker, and all the results have been taken. And after that, I have downloaded that file here. And here I'm not showing any. I'm not loading it on the. Right now, I'm not loading it on the SageMaker, but this file has been run on SageMaker. And now when you receive this file, you can upload this file in SageMaker and it will run as it is. So there is no change because all code has been already tested in SageMaker. Right now it is not in SageMaker. Okay. So I'm opening from my local machine and explaining. Just because of I don't want to open as unnecessary things and save charges if there are any charges or something. So, and there is no need for this demo, there is no need to run it from SageMaker. So I'm running it from local machine. So it's an insurance problem. So it's, I think many of you who have done machine learning, it's a famous problem. Many people solve it from Kaggle. So this data set is taken from Kaggle. I'm loading the CSV file, read underscore CSV. First, I have done some EDA to show you like EDA is exactly same as we do on local machine with local commands like pandas, scikit-learn commands. Then we'll do linear regression by scikit-learn. So by scikit-learn means I'm not using any SageMaker features. So it is as if we are doing it on local machine. So doing on local machine, and if your Jupyter notebook is loaded on SageMaker, it is exactly same. You can use all those scikit-learn commands, pandas command, numpy commands, all Python 3 commands you can use on SageMaker without any exception. Okay, so it is same as running as local machine. So that's what this demo does, a scikit-learn demo. Then we have done, I have run a artificial neural network model just to improve the accuracy. And it is also done, we have not used any of the SageMaker features here as if it is running on local machine, but I have done I have run it on SageMaker, and believe me, it was very fast because of higher resources I have used, higher CPU I have used. So because of that, the running time was less than 10 minutes. Otherwise, in local machine, it takes more than a couple of hours. So that's the advantage of AWS. And then we'll see that linear regression we did previously by scikit-learn. We'll do same linear regression by SageMaker features. So this time we'll be using SageMaker features, okay, and check the accuracy and all. And after that, we'll do it same thing by XGBoost. And that XGBoost I'm not showing by scikit-learn. You can do it yourself. So XGBoost I'm directly running from SageMaker features. So if you want to do linear regression by SageMaker, so there are only these three generally these three main components there, which three algorithms are used. One is linear regression you can use using SageMaker. You can use ANN using SageMaker and using XGBoost using SageMaker. So if you know these, I think it's 100%, practically 100% regression for you. You don't need more than this to run regression on SageMaker. Okay, so XGBoost, linear regression, and ANN. You should know how to run it with SageMaker. So that's all is regression, almost 100% regression for you. So there are a couple of more, there might be a couple of more other algorithms, but so far SageMaker study which I have done, I have never seen anybody using other than XGBoost, linear regression, and ANN. So that's pretty much of it. 100% of regression for you. So let us go ahead. So we are first going into exploratory data analysis. So I have displayed the head. Just have a look at the just have a look at the columns. So which are variables: age, sex, BMI, children, smoker, region, and expenses. So these are the expenses we are going to predict. It's a continuous variable. You can see it's a continuous variable, right? So these are nothing but your insurance charges. So based on age, sex, BMI, children, where how many children that guy has, one, two, three, whatever children, and smoker, whether it is smoker and region, which region he belongs to. It's a US data. So we have to predict we have to predict how much in insurance premium that insurance company will charge. Based on only these, based on these features, we have to predict insurance. Okay, so insurance is nothing but a very continuous variable, as you can see. Okay, so I check null. So like by luck, we don't have any null here. Then we have taken the info on the data set. So it's very primitive. Then again displayed the head. Then you see sex unique. So as expected, we have only male and female as the two unique values in this. Then regions. So region unique means how many? We have four regions in the four US regions here. Southwest, Southeast, Northwest, Northeast. So these regions are there. So we have to convert each of these things into one hard encoded variable, right? So as we do for all machine learning problems, so that is required here also. So sex, like just say df, this is pandas column. Say dot apply. Dot apply is a usual method, which whatever you apply, dot apply means it will be applied on the entire column. So lambda function I am using. X is equal to 0 if x is equal to female. So for female we are coding 0 and male we are coding as 1. Similarly, smoker, non-smoker we are coding as 0 and smoker we are coding as 1. Same code. Then dummies we have four regions here, right? So we have four regions here. So lambda function will be difficult to use. So instead we are using directly get dummies method of pandas. So pandas dot get dummies df region. So df region is nothing but your column, region column, drop first equal to true. So this all is a very familiar code for elementary code for machine learning algorithm. So we get region dummies. So region dummies we got separate data set. And after that, what we do, we usually combine these two. So we combined DF means our DF was our original data set, and dummies just what we got dummies for region. One not encoding for regions, four regions. So we combined it. X is equal to 1 means we have combined column wise. So that is what after concatenate. Once we concat like this is this, and once we put the head, this is all your variables. So these are all. Now we can drop here regions. See regions already we have a one not encoded. So this region we can drop very safely because already we don't need this region now. So we have used region x is equal to 1. We have dropped it, dropped region column. Then now if you play the head, like you see everything is numeric. So now the data is ready for your machine learning algorithm. So describe is another command which we use to describe numeric columns. So here we are displaying the maximum, minimum, and usual statistical data on numeric columns. So all these are numeric columns. So all you will get count, minimum, standard deviation, 25 percentile, 75 percentile max for all the numeric columns you can see here. So then we are visualizing the data set. I'm showing this everything to you because I just want to demonstrate that the commands in SageMaker, once you load your Jupyter notebook in SageMaker, the commands are exactly same. There is no difference. So same commands are there as if you are using it in your local machine. Same commands are running. So histograms we are running on data frame. So it will run histograms. So these are all are numeric columns. So all the histograms are plotted. I'm not going into details of this histogram. Then regression plot, we are just plotting like what kind of data we have. So age versus expenses. Expenses is nothing but our target variable. Age is one of the predictor variable, and expenses is y variable, target variable. So this is how it looks like. And the line. So it is not much of linear data. So you see it is all over scattered. So it will, when if you run simple linear regression, your accuracy will not be good. And same thing we'll see when we run it. So see, it is not along a straight line. So straight line is here. You can see the straight line, but data is scattered all along. So it's not a great fit. The straight line is not a great fit here. Okay, so now let us go ahead, prepare trend data. So we are doing XY as usual. So expenses, when we drop expenses, all the columns are your dependent variable, and we take expenses which was target variable in Y. So now we have X and Y, and then X and Y we have, then we convert them into float 32. Sometimes it is required or advisable while working with SageMaker that you convert it into float 32. So everything, whatever we had, we converted into float 32. So this is, it is one of the data type in Python, which is contains with decimal values. So with Y, we have done the reshaping. So this reshaping just we have done in single. So we are reshaping it in a single dimension vector, which is required. Then we apply this thing, train and test split. So I think this is a familiar code. So we get X train, X test, Y train, and Y test. So this is all 4 we get. And test data, test size, like 70% is your train size and 30% is your test size. Random state we are giving. So I think you are already aware why we give random state. Because random state, like if this number, if you provide all the time, if you run with the same random state 100, it will ensure the repeatability of your results. Otherwise, random allocation to training and testing will be different. Record will be different. Each time you run it, the random record allocation to train and test will be different. So the result, the model evaluation result, what you see may be different because X train and X train and X train, all these 4 will vary. Like if each with every run, random things will be allocated to these things, right? So they may vary each time when you run. But if you provide a random state, I think you get each time the records which are allocated in these 4 arrays, so it will be same. So for result repeatability, we use this random state. And as you know that in linear regression, it is advisable to do the scaling before we put into the algorithm. You are already aware, I'm not getting into detail. So we are using standard scaler here, fit transform for X train, X test, and fit transform for Y train and Y test. So this brings all the 4. This brings all these 4 data sets to one single scale it brings. So maximum is 1 and minimum is 0. So that's what standard scaler does. So these are all customary steps before we apply linear regression. So I take a minute break here. And so if anybody wants me to repeat anything or if it is not understood so far anything, Sauji or anybody has, Puraswani sir joined?
Yes, sir.
Namaskar, sir. So anybody has any difficulty? So any, I think these are all usual and very familiar code so far we have done so far. No, nothing is new. So anybody any difficulty, Sauji?
I am trying to do it in SageMaker.
Yeah.
But I am not even able to set up the role itself.
Which one?
I'm trying to.
So let us see it after the let us see after our class is over. Okay. Mm-hmm. So what you are not able to see set up the role in SageMaker. So let us see after the class. Okay. So we'll have a look into. You share the screen and then we will look into it. So let us first complete this. Let us first complete this session, and then we'll look into your problem because it is not related with this session. It is related to the more of housekeeping and setup of SageMaker. So we'll look into it. So now we are using scikit-learn for doing linear regression analysis. So scikit-learn means as if it is I'm running on a local machine. I'm not changing any command. So I'm importing linear regression, the mean squared error, accuracy score. Accuracy score is nothing but your R square. Instantiating linear regression and fitting extend and wide range. So extend and wide range is nothing but your scale data here, whatever we did here in step 14 here, whatever you did, the same thing we are calling here and fitting it. So this fit is nothing but your model training. So once the model training is done, you have X test, Y test, you can do the prediction. Like you can do the prediction, or first before prediction, actually I have done the score. Score means I'm calculating accuracy score, R square score. So I passed X test, Y test. So X test and Y test was unseen data. So this unseen data we are passing into our linear regression model. So this is our linear regression model. See, this is our linear regression model. We did fit on that. Same linear regression object we are using here. So all the weights and constant term is stored in this. So we are using here to calculate the calculating the R square. See, R square is very worst actually. Even if you do a random guess, it is a probability that you will do 50% correct. Means 0.5 it should come. But your R square is coming only 0.1. So it is poorest of poor result you can get. Okay, so reason is known to us, because when we draw this kind of regression plot, we see that variables are not linearly related to the y variable. Right? Expenses is y, right? So age is one of the x. So x1 is not linearly related. So similarly, if we plot other x variable, so probably they are also not linearly related. So our linear regression is failing here. Okay, so linear regression. So, but still we know how to do it, right? If this variable like x1, x2, all these variables, x1, x2, and all these variables, if they were linearly related with y, that is expenses, then we could have got a better accuracy here. But still procedure remains the same, right? So now we are not getting good accuracy. So we stop at that, and we proceed with other procedure, with other methods. So like if local machine, if you are running, you are getting a 10% accuracy. Same thing if you run it on SageMaker, you will get similar accuracy, because accuracy linear regression will not change, right? But we'll still see the procedure how to do it. We'll see how to do it SageMaker. So now you have to be little attentive, because we are getting into more specific code which is specific to SageMaker. Okay. So first of all, we are importing SageMaker. So this file is mind it, this file is running in SageMaker Studio inside SageMaker environment. So SageMaker is a AWS machine learning environment and service. So first of all, you have to import SageMaker, which is nothing but AWS machine learning environment. In that, you have to do all your machine learning things. So you import SageMaker. Then you are importing something called Boto3. So name sounds very very strange, but Boto3 is a AWS software development kit for Python. So simple, Boto3 is a software AWS specific software development kit for Python. Boto3 allows to write software that can use S3 bucket. So S3 bucket, we know that it is nothing but your storage directory in which we store our file and data. So Boto3 allows to write software that can use S3 bucket and EC2. EC2 is nothing but your machine instance on which you are using, on which you are running your Jupyter notebook and other services. So Boto3 is one of the basic software development kit, AWS software development kit, which allows us to use AWS services, including EC2 and S3. Very basic, so we have to import it always. Now we have to create a session. So from SageMaker, import session. So this is a SageMaker session. So we have to create a SageMaker session. So we created a SageMaker session inside it. Now, in the SageMaker session, like we have just imported here, we have just imported session here. And in this code of line, SageMaker underscore session is equal to SageMaker dot session. We are making an object of session. Like linear regression, we first import, and then we make a, like with this bracket, we call that linear regression procedure to make an object of linear regression. So similarly, here we are making a session object. Here we are making a session object. Then bucket. So bucket means your directory. You assume bucket is you are just you are familiar with your Windows directory, right? So bucket is nothing but a like you can say AWS directory in which you store your files and data. So we are from that session object we are taking here. From that session object we are calling default bucket. So we are getting a default bucket. So whatever default bucket, default directory or default bucket that AWS is providing, we are calling that. So we are making an object of that. So this prefix. So now we are defining here a prefix. So what is prefix? So prefix is nothing but in that directory, in that bucket, you are making subdirectories, right? Because you will not dump every data into one parent directory, right? So you say bucket is a parent directory. So default bucket we got as a parent directory, and in that we'll have different subdirectories. So linear regression is nothing but name of subdirectory. This is name of subdirectory. It's a subdirectory within bucket. So now we get the execution role here. So execution role, we have to guess the execution role for this notebook instance. So whatever execution role you have set while defining IAM roles. So that execution role you have to get here to run your notebook instance. So that role you are getting. So this role and all you have defined while setting your notebook. Already you defined, so it's a part of setup. So you already did in a status class. So we just get the execution role, SageMaker. So you got a role. Okay. So now if you are printing the role, if you want to print the role, it looks like this. So something cryptic actually. So this is the code for that this execution role. So I had given complete admin role for my. So I'm executing it from my machine learning user, ML underscore user kind of. My username is ML underscore user, and that is having all admin rights. So this is the code of that. So it is using, now we see the shape 936, 8 columns. So 8 x1 to x8, right? White range. So it is having only one, same number of 936 record and only one column. So now import IO. So IO is another thing which we don't do in our local machine. So it is SageMaker specific. So what is IO? This module allows various type of IO operations like text IO, binary IO, and raw IO. So input-output operations of various types like text IO, like whatever IO we do, binary IO or raw IO we do. So that is provided by this package, this library IO directory. Then NumPy, everybody is aware. NumPy I have imported. And then from SageMaker.amazon.common, import SageMaker.amazon.common. So it is one more SageMaker specific library from which we are importing SmaC. So SmaC is a common purpose, general purpose library which we are importing. So now see what we are doing. Now next, convert the data from NumPy array. So NumPy array, like whatever data is here we have in X-train, Y-train. So X-train, Y-train data, whatever we have here, X-train, Y-train data. So it's all NumPy arrays, right? It's all NumPy arrays. It's all NumPy arrays. So what we are doing here is convert the data from NumPy array format to record IO format. So I'm not getting into record IO format, but record IO format is something which is required by SageMaker. So it will not, if you put directly into NumPy format, it will not take. So record IO, I guess, is some kind of common format only, like your JSON and all that. So it's a kind of some common format, record IO. I think you can Google it, record IO format. What is record IO format? So in this format, you need data to run it to SageMaker. So that's what is required. So NumPy array, we need to convert it to record IO format. So first we say create a buffer. So see, all these steps, if you are worried or you are seeing it is very new, don't worry, because for every machine learning problem with SageMaker, this code will be repeated. This code will be repeated. So you have to just copy and paste it to next problem. So when we'll do next problem with classification, you will see the same code being repeated. So once you understand it, it is forever. All the time you have to repeat it. So see now, so first of all, you create a buffer. So it is an in-memory buffer, in-memory byte array. Buffer is a buffer to write the data. Say whatever your train data and test data you are having, train data right now, because we are training the algorithm. So whatever train data X and Y you are having, both X and Y, X train and Y train. So that will write into this in-memory byte array. So first we got the instance IO dot byte IO. This we got buffer. Now we are writing into that buffer. Once we got this buffer, so we are writing into this buffer. See how we are writing. First of all, SMAC. So SMAC is a general purpose library we had imported. So SMAC dot write NumPy to a dense tensor. So NumPy is your always a lot of zeros are there, and so a lot of zeros are there. We don't want those zeros. We don't form like we want to write in the data in the form of a dense tensor. So I think I will suggest you. I'm not getting into detail, but if you don't know tensor, then you need to know the tensor. What is a tensor? And if you don't know what is a dense tensor, I think you need to Google it out. I'm not getting into detail because it is something very primitive, and I think you need to get into detail. So many people don't know dense tensor, and many people don't know dense tensor. So like dense tensor means we are unnecessarily all the zero which are there in the NumPy array, we are removing them. And wherever only meaningful values are there, only that we are keeping. So that will save our space in memory because you are writing in memory. Okay. So buffer. So this buffer we had created here. So this buffer, we are writing into buffer. What we are writing into buffer? So extending we are writing into buffer, and white train reshape we are doing it as a single form vector. So we are reshaping this into a single line vector white train, and we are writing it into buffer. So X train and Y train we are writing into memory buffer. So your in-memory buffer, your active memory, in that we are writing it. So active memory of AWS, we are writing X train and Y train. Why we are writing it? Because we want to use this both these X train and Y train to train our algorithm. So we are writing here, and we are using SMAC library, which is a general purpose library. So SMAC library has this method, write NumPy to dense tensor. So dense tensor means I already told you we are removing all the meaningless zeros from NumPy, and only where meaningful values are there, 0.01, 0.13, wherever meaningful values are there, that only we are keeping. So that is what is dense tensor. And we are writing in buffer. Say, see, buffer we are using here. Buffer we are writing, and then we are writing X train and Y train. Okay. So then we are seeking 0. So I think many of you might be familiar why we are seeking 0. So any answers to this? Why we are seeking to 0? Buffer dot seek 0. Any answers? Any guesses? Any wild guess? Soman Sahuji, any wild guess? Puraswani sir, why we are doing this? Seeking 0. So I think IO operation, if you have worked with IO operations, I think you are already familiar that your pointer keeps on moving. Once you read something, your pointer moves to next record to read, right? So here also, to get to the start of this memory, like now data is written in memory buffer, right? So your pointer may be somewhere at the end or somewhere. So you want your pointer, means you want to read your file from 0, right from the beginning. So to bring your pointer to beginning, we do this. This is a customary operation which we do. Buffer dot seek 0. So that will bring pointer to 0. Nothing. It is nothing but suppose you are reading a page, and if you are in the middle of the page, and you want to start from again, so you have to put your eyes again on the very first word, right? So it is similar to that. So then next you take any challenge here so far in this? First time it may look little weird because it is unfamiliar code, but I just told it is just to be copy from here and paste into next problem. That's what you
So
have to do.
suppose if we have a Python code which is already running, right, on Google Colab Pro or like, so just
Yeah,
I need to copy paste this standard code and make it compatible with AWS, right?
yeah, exactly, exactly.
Oh,
So like, so yeah, so you have Google, you have in Google Colab running means you have this X train, Y train, right? So now you want to write for training linear regression in linear regression in AWS, you write into buffer. You need to write into buffer. So just copy this data, your code will be okay. You will be okay. 100% you will be okay all the time. And here also, sorry. So here also before that, you have to do all these steps. Import SageMaker, import Boto3, import session, create a session object. Then you have to create a backup. And see, whenever you are using S3, like whenever you are using S3 specific linear regression, any S3 specific code, it requires that your data should be in S3 bucket. Your data should always be in S3 bucket. So S3 bucket is nothing but your storage in AWS. So this should be an S3 bucket. So here we got S3 bucket, we got a prefix. And if you want, you can create a couple of more prefix with this, like AW, whatever you want to write, you can write. So you can create with this. So the prefix, then role you have to get, and then you have to repeat all these steps. So once you have this, means now your data X train and Y train is put into buffer, and your pointer is already on 0. So you can start reading from the first word. So that's what it means. Now let us get into next steps. Now जो है like first we have imported OS already. So linear, this key your key is the name of the file. We are giving name of the file. We are defining the name of the file, linear regression, linear train file. Upload the data in record IO format to S3 bucket. So now we are uploading the data into record IO format in S3 bucket. So I told it is required in record IO format. So we are taking Boto3 resource. Resource means we are taking S3 bucket. So Boto3, from Boto3 we are taking S3 bucket resource. Then we are taking this bucket. So in S3, this is what is your resource. Then what bucket we are getting? So this bucket we had defined earlier, right? So this bucket we had defined earlier. Here you see bucket. We got a default bucket, right? Here a default bucket. So here we got default bucket. So this default bucket you got here, default bucket. Then join path with prefix. Joining the concatenating, you are joining the path prefix with prefix, and then you are getting train and then key. So like it will be printed later on. And then upload the file object of whatever you had written in buffer here. Whatever you are written in buffer here, like here, whatever we had written in buffer. Now we are writing that into S3 bucket. And S3 bucket, with this we are providing the complete path. So see, the S3 train data, and you see the path here. So linear regressor was the key we had provided here. Linear regressor was the key we provided here, right? Somewhere. Linear regression session here. Linear, yeah, here. Prefix. So this prefix has come here. Prefix has come here. So this is the till here, it is default bucket. Okay, that bucket you created, default bucket. Linear regressor is the first. Then you have defined train inside that, and then you have defined this file. So this is your linear regression file. In linear regressor, you have a train folder, and in that train folder, you have this training file. In this training file, you have both X and Y. X train, Y train, both is there, both are there. And now you have written it into S3 bucket. So S3 bucket, writing into S3 bucket is a requirement. So here and you see, first you loaded with this data, you loaded it into buffer, memory. You loaded it into memory. You got pointer to buffer 0. See, buffer 0, you got the pointer. Now everything is memory. It is not there in S3 bucket. You have to write it into S3 bucket. So with this code, you write your buffer. See, upload You are uploading file object buffer. So whatever your buffer object was there, you are writing in S3 bucket. So once you are loaded in the S3 bucket, so this is your file name. This is your file name, and you are divided file name here. So till here, anybody any challenge? It's unseen code, but again, to write into S3 bucket, you copy same code, your job will be done. But better you understand and copy. But every time you do any problem in your SageMaker, you have to use the same code to write into. Before you call your algorithm, you have to write into S3 bucket. Same code can be used. So again and again, it is one time and lifetime code for you. You understand one time, it is for your lifetime. Okay. So is it any challenge here? So here we first wrote data into buffer. Means whatever CSV file was there, we loaded in record IO format in buffer object. In buffer we have loaded. Buffer in loaded means like in layman terms, in computer's language we loaded it. Computer's memory we loaded it, and from memory we have written into hard disk. So hard disk for AWS is nothing but your S3 bucket. So is there any problem here, Shailesh, Dr. Shailesh, Sauji?
No.
And Sauji or anybody,
Yes,
Soman?
yes, sir.
It is very simple, right? So now,
Yeah,
and
it's
each
simple.
time you have to use it looks tough because it is unfamiliar code. But once you understand it, lifetime it is same code. So now output location you are defining. Output location means what? Like once your model runs, it will produce some output, right? It will produce weights and it will produce beta values. So all that model equation will be your model output. So you have to store it somewhere. So that output location also you have to provide. So create an output location in S3 bucket where linear regression output will be stored. So linear regression will run, it will create a linear regression equation. So it will have some intercept and it will have beta values. So all that to be stored, right? So where we have to store it? So we are defining a location. So here we are defining a string. See here, S3, then these two blank values, the blank brackets and output. So output is a new directory we are defining here. So these are subdirectories. You see, these are subdirectories. So first, within the first curly bracket, your bucket will come. Bucket is nothing but the default bucket which we called previously, right? So default bucket will be stored in the first blank, and second blank your prefix will be stored. So prefix is nothing but your trained data. So now when we print it, so our training output will be available in. So training output will be available in. See the path here. So this S3 bucket is a default. This is your default bucket. So this you don't have to do anything. You got it default bucket. These two you defined, right? So this output is defined here, and this was defined earlier. So this is how you got your path. So this simple path is defined. Now, anybody any challenge here? So I think you have understood now from where linear regression came, from where output came, from where this came. Is it understood, Dr. Shailesh?
Yeah, actually, one question I have is, so in Colab we read all the database from our Google Drive, right?
Yeah.
Here, suppose if I have to take something from Kaggle or
No.
maybe from
It
local
has
drive,
to be
then
there in
how?
S3 bucket. No.
So
If it
okay,
is there in Kaggle and all, you first store it in the local memory of AWS Studio,
huh.
and from there you have to write it in S3 bucket. There is no other code. So this code you have to like you cannot run from any Google Drive or anything is not allowed. Compulsorily it has to be there in S3 bucket. So you have to write this code and this code. So this code and this code writing is compulsory so that whatever data you have should be stored in S3 bucket. Otherwise, you cannot do anything in AWS SageMaker. Okay. So that is the
Yeah, but
primary compulsory requirement.
no, I understood that, but sometimes this database is very large, right? So
Yeah.
handling will be very tough now, because last
No,
time what
then
happened
you
is,
have to use some techniques of big data, and you have to small pieces you have to run and then keep on writing. So the handling big data is very different technique, right? But still you have to write it into S3 bucket. It can take, like, resources are infinite here. So even if your data is 100 gigabyte or 200 or 1000 gigabyte, you can write it into S3 bucket. But how to read it from Google Drive and write it here? You have to break into small chunks and then load it. So it's a different problem actually.
Okay.
So differently you have to do it, but still you have to load it into S3 bucket.
Because sometimes we had a collaboration with JSON file and all, na?
Yeah.
So, because when I tried it manually, then it was hours and hours it was taking, but JSON file was a minutes of click, right?
Yeah. So no, that's a different problem. How to load it? How to
Okay.
load large data? How to load big data into S3? It's a very different problem, but there are techniques to do it. Basically, layman's language, you have to break into manageable chunks and then upload it.
Okay.
So the code for that will be a bit different. How to load it. So right now we are dealing with say manageable files, say 1 GB up to 2 GB, 3 GB, like that we are handling normal files. So now our S3 bucket, your train data is loaded. Mind it, train data means X train and Y train both are loaded. Okay, both are loaded. Now we are getting into the main thing, very interesting part of it, which is nothing but your training. So Sauji, till this part, any challenge? Sauji, are you there?
Sorry, मैं म्यूट में बोल रहा था. No challenge.
Yeah, anybody? Puraswamy sir?
No, sir.
And both students?
No, sir. It's comfortable so far.
Yeah. So now we are first of all defining a container. So container, if you are aware, something like Docker container or those kind of things. So in the container, we have the image of that particular algorithm. So that image algorithms are already built into SageMaker. So that container we have to call. In that container, everything what is required to run that particular algorithm is available. So that container we have to call. So from SageMaker, Amazon estimator. So in the Amazon, our regressor is called estimator. So Amazon estimator means regression algorithm. So Amazon regressor import get image URI. Okay, so we are getting image of the algorithm. So from that container, we are getting get image URI. Once we have imported that get image URI, Boto3 session, we have session dot region name. So I think Amazon, once we do setup, we have region name like North Virginia, Ohio, Mumbai, or those kind of regions are there. Now different region, different services are available. But you want any service, you can load any region, right? Maybe some microsecond delay may be there, but you can upload any region in the world and you can get any service practically. So hardly makes any difference. So whatever region you are running your file currently, your Jupyter file in whatever region it is currently running. So this code will fetch that particular region name, and then you have to call linear. So what container we are making? It is standard code. Okay, you cannot change it. It has to be linear dash learner. So it is a standard code. So this you want now linear learner. So you are calling a learner. You are calling a container for linear learner. So that's what you got. What a object of it. Now once you got it, we use it to now we get into our real algorithm, defining algorithm. So see how algorithm is now we are defining here. Whatever scikit-learn we call linear regression with two brackets, simple brackets, whatever we call. So it is a similar code here. SageMaker dot estimator container. So we have to first define the container here, which we have defined here. So all is this standard code. So container we are defining. That means we are getting the container image, that image containing algorithm. So this container, I think somebody is speaking here. So you have to go on mute, guys. So there's someone. So then container you got. Now see if you are doing XGBoost. So here only you have to define XGBoost. But the estimator code will remain the same. If you are defining logistic regression, here you have to change. That's here you have to change. Whatever I'm highlighting, no. So while for logistic regression, you have to change here. But this code will remain the same. This code will remain the same.
You're not able to see the screen.
Yeah, not able to. Yeah, I'll share this thing. Sorry. So, now?
Yes, sir.
Yes.
Visible, no? Yeah, sorry about that. So see, what I mean to say that this code, this particular piece of code will remain same whether it is a logistic regression, whether it is a linear regression, or whether it is a XGBoost. This code will remain same. Whatever I have highlighted here in light blue will remain the same. What difference will be there? So only container when we are calling. So that container will call for different algorithm, different containers there that will call, and that container will invite here. So this code will not change. So again, for linear regression, logistic regression, XGBoost, and many other algorithms, this code will remain the same. Only while calling the container, these things will vary. I have called linear learner, so that time I may call XGBoost learner or something else. So only this container, this code will change. So now I have changed the container role. I think whatever role we have defined at the time of role we defined, right? At the start we defined role. So that role will come. Then linear train instance count. So how many parallel instance you can run. So right now we are learning a free instance. So maybe 2 or 3 instances it cannot allowed. But once you get into paid version, multiple parallel instance it can allow. So it is important while running things like XGBoost and all. Many parallel instance, if you run your computation will be faster. But right now we are into free instance, so we are using only one. If you use two, I think it will give error. It will not give. It will not allow you because now training instance type. This is very so important. Train instance type. So this what I have chosen here. Export large. C4 export large. This is chargeable. So Himanshu, which is free one? C3 medium is free one, right?
No, sir. It's ML-T3 medium.
Yeah, ML. If you define here ML.T3.medium, charges will not be there, but your execution will be slow. I wanted my execution to be fast, so I paid some charges and I use this MLC4X large. So you have to be careful here. So ML.T3 medium, if you use ML.T3.medium, then your charges will not be there. If you are using same thing which I am running, very minor charges are there, less than $1 or something, so you can still use it, and you will be more comfortable and convenient things will be there. So output path we have already defined output location, and SageMaker session. This SageMaker session also we have defined earlier. So all these things are defined earlier. Only in this thing, new thing is this container. So container we defined here. Here we define container, and which instance we are choosing means which machine we are choosing to run it. So this machine we are choosing. So this machine is little bit chargeable, very less though charges. So if you want convenience, you have to pay. Okay, so better use a better one. Or if you don't want to pay, use ml.t3.medium. Then once, so this is the customary here. Estimator, you have called estimator. You have made an linear object out of it. Now when we define in scikit-learn, whatever hyperparameters are there, so linear regressor or XGBoost regressor, whatever hyperparameters are there, in the spherical brackets only we invite all the hyperparameters, right? Max depth is how much, or whatever are hyperparameters we invite in that only. But here it is both are separate. So here first we define the algorithm and we make the instance of it, and then on that we set the hyperparameters. So hyperparameters is feature dimensions. So this feature dimension is not there in scikit-learn. So here you have to give feature dimension. Feature dimension means x1 to x set, right? We have eight x variables, right? x1 to x set. So here we have to give that number. Then predictor type you have to give regressor because we are doing regression operation. Mini batch size. So it is something new which is not there in scikit-learn in case of linear regression. In case of linear regression, we don't have any batch size or epoch. So batch size and epoch are there in your neural networks. But here in SageMaker, you have to specify the batch size and you have to specify the epochs. So epochs, everyone knows it is nothing but your number of iterations you want to go through with this kind of this. How many iterations you want to complete with the complete data set? One traversing of one complete data set is one iteration. Like how many iterations you want? So epochs are 100 and mini base size is 100 and number of models. So like how many number of models you want to create? 32 models I have given. So which is fairly large. And loss function also is absolute loss. So I think these things are something new for SageMaker. So and note that all these are hyperparameters. So there are loss also. You can provide multiple loss like mean squared value or R2 or there are many multiple things which you can provide. Number of models you can try 50 model, 100 model. Epochs you can try more. Batch size you can try it more. So if you have done little bit of deep learning, you will know that the batch size is a very important and very significant hyperparameter. The same thing is here also. And these things are like these, you can also try this with like feature dimension. Sometimes you try 8, then you try less. You can try. So all these are hyperparameters. So which all these can be tuned. And there is a separate method in SageMaker on how to tune the hyperparameter. So all these can be tuned because these are all variables. They can be tuned. And why we tune hyperparameter? To get the best value of R2. Right? That's why. The best value of best results out of linear regressor we want. That's why we tune hyperparameter. So all these are regressor and there are many more hyperparameters in SageMaker. We have to see the documentation. So it's documentation like if you see the documentation of this SageMaker.estimator.estimator documentation is very easily available and it is available in the open web. You need not go to any SageMaker or just open the internet. It is available and you will see there are a lot of other hyperparameters also available. So once you become a little advanced user, I think you have to make yourself familiar with those hyperparameters. For now, it is enough. Then we say fit. Fit is same. So fit is here. We have to go give in the form of a directory. So train.s3 train data. So this is your train data you have to give. So S3 train data is nothing but your S3 bucket, which is it is nothing but your S3 bucket variable which is containing your training data. And mind it, training data contains both X and Y train. So in this form you have to give here train data and then S3 bucket, in which this is the name of S3 bucket, which is containing your train data. So you say fit. So now it will do the fitting. But usually this kind of fitting takes lot more time it takes. So see how many, I have not noted the time, but it takes a lot of time and a lot of output it will throw, which is more of it if you want to read it. You can read it by if you little bit carefully you read it, but generally it is not readable. So everything it is throwing output and once you get this training done, so once you get your training done, you can, if you want to deploy it, before this, since this training takes a lot of time in AWS, so practice is you first run it with scikit-learn. Simple. We don't call any AWS specific things. Run it with scikit-learn outside in the SageMaker only. Use only scikit-learn commands so that it runs very quickly. And once you are satisfied with the result somewhere near that, then you can use this scikit-learn specific code because it takes more time. Then you will ask me what is the advantage of if AWS takes more time, what is the advantage? So this is the advantage. The training instance size, the type of machine you can use, the type of parallel jobs you can give. So this makes your job very easy and you can deploy on a large scale. So now you got the train. Now with this step, you have trained your linear model. So once you train it, how to deploy the model, trained model. So deploy with scikit-learn and Flask and all, it's a bit tedious in Python. But see here deployment is very easy. Just say linear.deploy. Linear means your linear was nothing but your model. This is your model object dot deploy. model update dot deploy, initial instance count equal to 1, and then again you have to give which kind of machine you want to use to deploy. So I have given a larger machine. So if you don't want any charges, give ml.t3.medium. But I said a little bit okay, little bit spending a little bit dollar for convenience. So I have given this to deploy. And with this, it take a couple of minutes to deploy. Like it's not an instant process. So like this, it will start like 1, 2, like this you see here, highlighted here in blue. So it will start like this. It will slowly start, and when this exclamation mark comes, means it is deployed. Now it is deployed means it is available on the internet, and anybody from anywhere in the world can access it, right? So it is that easy to deploy it. But remember, deploying this is chargeable. It makes you charges. So really, if you want to deploy it for a longer time, and if there any business benefit, then only you will keep it on. Otherwise, better test it and delete it. So see, now we are doing predictor. So for this predictor, we need your deployed model. The deployed model requires data in text or CSV format. So text or CSV format. So you import CSV serializer and JSON deserializer. So this code is also standard. And linear regressor dot serializer is equal to CSV serializer, and linear regressor dot deserializer is equal to JSON deserializer. So I think these two commands, even I have marked this as the question mark, and to be very honest with you, I need to do some R&D on this, that what they do. But right now they are working for me, so I have used them as it is. But maybe in the next class I'll do some R&D and explain you what you do. But maybe Sahuji, if you want to throw some light on this, what the serializer will do and JSON deserializer will do. If you have any idea, you can tell. Otherwise, we can proceed for now. And in the next class, I promise you to explain both this line of code. Otherwise, everything is explained actually. So, Sahuji, any idea?
No, no.
No problem, no problem. So next class, I will explain this. Okay, I promise to explain this. So now you have the linear regressor ready. So you can use the, see, linear regressor is nothing but your deployed model. From deployed model, you are doing the prediction for X test. For X test, predictions are stored in result. So if you see the results, they are in a little strange format. So it is in, say, in this format. So prediction, in a prediction is nothing but your heading. All prediction are in a dictionary format. So all in the dictionary, inside the dictionary, you have a list of dictionaries. So these are nothing but your predictions. These are nothing here 0.9, 0.7, minus 0.92, minus 0.97, minus 0.29, minus 0.49, minus 0.85. All these are your predictions. So these are in this format. So we have to open this, unfold this format. So very easy step to unfold this format. Prediction equal to np.array r. So we are deploying a for loop. So like r score for r in result. We are just unfolding it, right? So we are just unfolding this dictionary and this list. So we are unfolding it with this simple line of command, simple Python command, and we are getting our predictions in the form of this list. So it's an array list. Sorry, it's an array. So we are getting in the form of this. So now you will tell me how can my insurance premium be negative, right? So these are all negative values. A lot of values are negative. So they are coming negative because we did scaling, some kind of scaling we did, standard scalar we used, right? On the result, we used the standard scalar. So these are all standardized, normalized, standardized results. They are not actual values. So you have to convert it into normal format, right? So prediction.shape, we got this is the shape of your test data. So now you have to do the inverse transform, right? So I think if you have done scaling in a scikit-learn also, so this inverse transform you have to do to get your real values. So like scalar.y inverse transform prediction. So predictions you are doing inverse transform, and for prediction is nothing but your y predicted, right? This is y predicted. So y predicted you got it, and then y test also we had scaled it. So we did inverse transform for that also. So both these y and x, y predict original and y predict y test original, they are in real, like whatever values are expected in that format they are. You can print and see. And with this now you can print that root mean square error, mean absolute error, and R square. So these things I am not going into detail. These are very basic for linear regression. So all these are model evaluation parameters. So you can go into detail. So many people are interested in just R square. So you see R square. So R square is again coming minus 0.19, which is kind of absurd. So we should get R square like 0.7, 0.8, 0.9. But here it is coming negative and that too very less value. So these results are absurd. Why absurd? Because our x1 to x8, whatever x variables we had, they are not really linearly related with the y. Premium insurance premium was y, right? So x1 to x8, they are not linear. None of them is linearly related to y. That's why linear regression is failing here. But that is not the objective here. Objective here is to tell you how to perform linear regression with the help of SageMaker. So this is the complete procedure. So whatever, irrespective of data you have, same procedure will apply. And if your data is linearly related, your x predictors, if x predictors are linearly related, then maybe this R square you will get 0.7, 0.8 or something like that. Okay. So this is just to show you this. Both I have shown you with the help of scikit-learn. We are getting only 10% R square, which is again absurd. And now with the help of SageMaker also, linear regression will be same, right? Only the way of doing was different. So we are expecting the same result. So results are again absurd. But the aim was to show you only the procedure. We are not concerned with the data. So that's what is done. The purpose is solved. Now next, we are telling that, just a second, Dr. Shailendra. Just a second, Dr. Shailendra. So now the regressors are not linearly related with your like whatever x values are there, x1 to x8, they are not linearly related with y. So what is next? So you expect there is some complex function which is relating x to y. So what is the natural thing? You apply ANN. You apply neural network, because they are called as universal function approximator. Whatever may be the kind of function between x and y, you are if you define a proper neural network model, it will be able to approximate it. So next step is obviously we have to try with a neural network. Okay. So I think Dr. Shailesh, I think I'll let you go. So yeah, go ahead.
Actually, here that is something new. Number of models is equal to 32.
Yeah.
So because in regression we have some definite sets of coefficients, right?
Yeah.
Whether it may be in matrix format or something, but here 32 models mean, is there any different terminology or number of models? Mean normally it should be a 1 fit, no?
We'll take it offline, Dr. Shailesh.
Okay, okay.
Yeah, I'll take it offline. So, I think next one already we started with 11:30 and 1 hour is already over. So after that we have a lot of things left and I don't think we can complete it today. So next thing is to try with neural networks, ANN, artificial neural network. So only thing I want to show you here is that see, artificial network we are getting decent R square. 82% accuracy we are getting, 82%. So which is very decent. So that's why like we are successful with ANN. So now I am not taking it. So I will maybe take it in a evening. If I take a class, then I'll take it evening. Otherwise, I would like to take it next week. So whatever you guys tell, we can take it up. So I'm still with this. Any questions here, Sauji or anybody till now? Any questions? Sauji, Puraswani Saab, any questions? So far, we have completed linear regression, how to do with scikit-learn and how to do with SageMaker. So that's completed. That's the aim of the today's, like, we have one milestone completed in we are not getting good results. That's why we are deploying, we are going ahead with neural networks. And I showed you with neural networks, we are getting a decent accuracy of 82%. So that means the function which is relating y with x is a very complex function, and neural network is able to capture that function. So, and one more very important things I want to tell you here is, you do have to run this, these whatever endpoint you have deployed here. See, this was your endpoint, right? So endpoint was, this was your endpoint. So this was your endpoint. Endpoint is nothing but your model, whatever model you had deployed. So this was linear regression you had deployed here. So with this command you had deployed, and you call your endpoint as linear regressor. So this linear regressor has to be deleted, otherwise वो constant meter चलता रहेगा. There will be a constant meter running, and your credit card will be debited. So to save yourself from nasty results, you never forget to run this particular command, linear regressor dot delete underscore endpoint. So this has to be, otherwise your unnecessarily your endpoint will keep running, and it will be available. But unnecessarily your charges will be there, because right now you are doing only testing. There is no business benefit of it, right? Where you are only learning, so better delete it without fail. Okay. So if no questions, then I stop recording here.